Hello, Algebra 2. Welcome to Quick Quiz 2, the LFR from LFR7, Solving Linear Systems. I've already made a video. There's already one on there that goes through my thought processes on how I decide which method to use for solving these. So if you haven't watched it already, watch that first, then come back to this. Okay? We've got there's actually 5 questions on here. We've got 4 just kind of problems like this where you need to make a decision on what method to use. Make sure that you've used at least each method one time. So between graphing, elimination, and substitution. And then for the 4th one, pick whatever you want and go wild. Number 1 in here, you are going to have to tell me the solving method, by the way, and your reason why. If I'm looking at number 1, just like I said in that the thought process one, I see these as an efficient way to graph because I have this looks like y equals mx plus b. So I'm going to do graphing. And why am I going to do graphing? Because these are in these equations are in slope-intercept form. And we've graphed millions and millions of times with slope-intercept form. So how would I do this first one? This first one, my y-intercept is 2. My slope is 1/3. So I'd rise 1, run 3, or go down 1 and left 3. My first equation looks a lot like this if I graph it out. This is 1. I'll call this A, call this one B. So this is A. B, my y-intercept is -1. My slope is 1/3, rise 1, run 3, down 1, left 3. This is kind of interesting. What the heck's going on here? Doesn't look like they touch. Hey, they don't touch. These are parallel lines. Huh. If they're parallel lines, they'll never touch. So there's no solution. There's no solution to this one. And what's a way we could kind of think about that to see? Well, look right here. They have the same slope. They have the same slope, but a different y-intercept. So they will never, ever touch. Very interesting. Very interesting. Let's look at number 2. Number 2. Let's see, I've got 4x minus y minus 1 equals 0 and -x plus 4 equals y. Well, I am seeing something right here. Again, you can choose whatever method you want. You just have to do all the methods at least one time. I am seeing here, for efficiency's sake, right now what I have, that second equation's already solved for one variable. So in my mind, I'm already thinking substitution. I'm going to use substitution. If you pick graphing or if you pick elimination, that's completely fine. Just tell me why and then do it. So substitution and why, one equation is already solved. Oops. For one variable. I've already got the first step done in substitution. I've solved one equation for one variable. So what I'm going to do is anywhere I see y in the other equation, I'm going to substitute in -x plus 4. And so what can I do with this, right? So anywhere I see, like I said, anywhere I see y, I'm going to replace it. So I've got 4x minus, put parentheses around the stuff that you're substituting in, -x plus 4, because you want to distribute whatever's on the outside of that parentheses to both terms, or all the terms that are on the inside. Because this would change. If this was just plus x minus or plus 4, that wouldn't come out the same. We have to distribute this -1 to both of these terms. So 4x plus x minus 4 minus 1 equals 0. Let's collect our like terms. 5x minus 5 equals 0. If I add 5 to both sides, I get 5x equals 5. And if I divide both sides by 5, x is 1. So in my solution, I know that x is 1. but I also need to find my y value. It'd be really nice if we had an equation that was already solved for y, like something equals y or y equals, oh, hey, look at that guy right there. Look at that guy right there. Negative x plus 4 equals y. We said x was 1, so negative 1 plus 4 equals y, so y equals 3. These cross when x is 1 and y is 3. If I graphed, they would cross right there, 1 comma 3. But instead I solved it using substitution. Let's go to the next page. Let's look at number 3 here. Ooh, interesting. And just a quick glance at this, I see once again, I've got one equation that's already solved for a variable. I'm going to use substitution again, which means I hope I can use elimination on number 4. Let me check that. Oh yeah, that looks good for that. So substitution. And why? One equation already solved for one variable. One equation's already solved for one variable. Okay, since we've already solved one equation for one variable, we can just substitute that in. Anywhere I see x in the other equation, I'm going to instead put y plus 1. Negative 16 plus 4y plus parentheses y plus 1 equals 0. Now in this case, we didn't actually need the parentheses, but it was nice to have them in there just in case. So this is like distributing a positive just 1 through. So negative 16 plus 4y plus y plus 1 equals 0. Collect your like terms and solve away. We've got negative, what is this, 5y right from here, and then negative 15, so 5y minus 15 equals 0. Add 15 to both sides. 5y equals 15. Divide by 5, y equals 3. So we know in our solution, we know what our y value is. We know it's 3. Once again, it'd be really nice if we had this one that said x equals something, and oh my goodness, we still do. X equals y plus 1. We said y was 3. X equals 3 plus 1, or 4. X equals 4. These two lines cross when x is 4 and y is 3. Let's look at our last one here. Oh, yes. After a quick glance, I look at this and I say, oh, I know I need to use the elimination method because I haven't done that yet. But I'm looking here, I'm saying, oh, hey, look right there. If I added these two things together, I'd get 0 and I could eliminate y. I'm going to use the elimination method. I can efficiently eliminate y. I can efficiently eliminate y. So let's write this out. I'm going to rewrite it just because I can. 2x minus 3y equals negative 9. 5x minus 4y equals negative 12. Oh, I'm sorry, 5x plus 3y. Oh, goodness. If I add these two equations together, I get 7x. This is 0 plus 0 equals negative 21. So what I've got right now is 7x equals negative 21. Divide both sides by 7. And x equals negative 3. So these two lines cross when x is negative 3, but what don't we know? You are correct. Microwave in the back. We don't know the y. So what we got to do here is plug this back in and solve. We got to plug this back in and solve. It doesn't matter which equation we do. I'm going to use the first one. So 2 times negative 3 minus 3y equals negative 9. If I multiply through and solve, I get negative 6 minus 3y equals negative 9. Add 6 to both sides. Negative 3y equals negative 3. Divide by negative 3 and y equals 1. These two cross when x is -3 and when y is 1. Now, I'm going to let you take a look at the 4 level on your own. I eventually will make a short video about just the 4 level, but for now, give it a shot. Hope you're doing well. Talk to you later.